Here we go, math students. Today we're looking at slope-intercept form. So writing linear functions using slope-intercept form. Some of the vocab that goes along with slope-intercept is, of course, what is slope-intercept form. So when we're talking slope-intercept form, we're talking about this y equals mx plus b. This is our equation that's written in slope-intercept form. So of course slope-intercept means it has a slope, and in this case the slope is right here. The m value, that coefficient, is the slope. So that's what we have right here. M is the slope. So the coefficient is whatever the slope value is. And the intercept word comes from this b. B is the y-intercept. It's where it crosses that y-axis. So most of the time we're going to use this 0, b, the ordered pair, as that y-intercept, where it crosses. Anytime it crosses that y-axis, it's going to be an ordered pair, 0, some number. That's going to be your y-intercept. Don't forget that slope measures the steepness of the graph. This example right here is a positive slope. It's going up to the right. If we had something that's a negative slope, it would be going down to the right. Okay. Slope again is your rise over run. So looking at that fraction, rise over run for the slope. So writing an equation in slope-intercept form means you're going to write the y and the x stay your variables, m is your slope, b is your y-intercept. So you're going to write those two, coefficient and the constant. So the constant is your y-intercept, coefficient, again, is your slope. And we have 3 examples we're going to do today. The first example, and for all of the examples, we're going to write an equation in slope-intercept form, and then we're also going to graph each of these. And I'm going to show you how to graph using a lot quicker method than having to set up a whole function table. Okay? Okay, so to start each of these problems, we're going to start with our y equals mx plus b. That's why I wrote it all these times across the top. So in our first one, we're going to write y equals mx plus b. So in this example, we have the m is -4/3. So they give you what that coefficient is. So we're going to write y equals, we're going to take the m out, the variable out, and put in a -4/3 x. It also tells you what the b value is. In this case, b is -2, so that means it crosses that y-axis at -2. That's our b value. There's the equation. It's that simple. You just plug in the m and the b numbers in place of those variables. So that's right in the equation. And now we're going to look at doing writing and drawing that graph. So when we graph this, remember this y-intercept really means that that's at the point 0, -2. All of those y-intercepts are at 0 and then the number for the y value. So when we graph 0, -2, I'm going to go 0, -2 and put the dot on the graph. So that's our y-intercept. That's our starting point. Remember back when we were writing equations, this is like our a sub 0 ordered pair. So that's our a sub 0. That's where we start on the y-axis. And then this one here is our slope, or that's what it's changing by each time. That's like the d value. So since this is our slope, remember slope is rise over run. In this case, it's -4/3. So we're going to do just that. We're going to start at that 0, -2, and rise -4 means I'm going to go down 4. 1, 2, 3, 4. Run 3, since it's positive, it goes to the right. When I rise -4 and run 3, I'm at this new ordered pair, which happens to be 3 down here to the -6. So the ordered pair isn't that important. What is important is where that dot lands. And then we can just keep doing that. 1, 2, 3, 4, 1, 2, 3. That's where the next ordered pair lands. And then you can go in the other direction as well. So if you go up 4, 1, 2, 3, 4, and to the left 3, 1, 2, 3. That would be just like if your line had 4 over -3. Up 4 and to the left 3. So now when we're graphing this, we can look at just connect the dots, and then you have your line graphed. So we have our ordered pair, 0, -2, that's our y-intercept, and then our slope is -4/3, so it goes down to the right because it's a negative slope. So we've written the equation, and we have successfully graphed it without having to do a big function table. Here's our example 2. We're going to write an equation, and we're going to graph it. Okay? So when we write an equation for number 2, so we've got 6, -8. That means this line goes through +6, -8. So 1, 2, 3, 4, 5, 6, and -8. 1, 2, 3, 4, 5, 6, 7. Of course, it doesn't fit on my graph. All right, and then we also want to graph 0, -4. 1, 2, 3, 4. All right, so here we've got a picture of what the line looks like. So again, if we want to connect those dots, oops, if I could draw a straight line, that'd be awesome. So what we're going to be looking at here is we know that it's y equals mx plus b. Well, we already know the b value here because of this ordered pair. There's our b value. B is -4 because of this ordered pair where it crosses the y-axis. So we know this is -4. What we're missing here is the m. We need to figure out what is that slope of this line in between these 2 points. Now, a couple things you can do to find the slope of the line. You can count and find out where does this line cross. Okay, if that was a nice straight line, where does it cross? What ordered pair does it cross? And you can count rise and run, rise and run. Okay, so that's one method. You can also look at how far did the y's change and how far did the x's change. So we've done that before. How far did the y's change? In this case, we've got delta y, delta x. Okay, you want to know that the y's are changing from -8 to -4. They went up 4. And the x's from 6 down to 0, they went down 6. So they were a -6. Well, we can simplify 4 over -6 as -2/3 for the slope. So the equation is y equals -2/3 x plus -4. And then again, back to the graph, you can, using a straight edge on your graph, if you count up to 1, 2, and then 1, 2, 3 backwards, you can see that it really, if I would have drawn the line straight with a straight edge, it goes through that ordered pair, and then you can continue up 2, 1, 2 over 3. There's your next dot. So you can be finding that rise and run from the ordered pairs as well, finding where the graph crosses right on those corners. Okay, so we wrote the equation and we graphed it. Okay, again, the equation, we were given that y-intercept as one of the ordered pairs, and the other missing piece, the m that we were missing, came from finding the change in y and the change in x. Okay, delta y, delta x. So y over x again for those slopes. And in our third example, we're going to be looking at, again, writing it in slope-intercept form, but then also looking at the graph. So in this one, we're not given those ordered pairs that cross the y-axis. So I'm going to first just graph these ordered pairs. 1, 3, okay, and 3, 1, 2, 3, negative 1. Okay, I'm going to be a little more precise with my graph this time, and connecting the dots. Okay, notice it goes through another ordered pair right here. Okay, and then if you want, you can count those dots. So in this, from one dot to the next, it goes up, 2, to the left, 1, up, 2, to the left, 1. So you're finding that rise and you're finding that run. What's the vertical change and the horizontal change? So from this graph you can count, or you can just use that rise and run to help you find the slope. And you can also find the slope using those delta x or delta y over delta x. So the y's change from 3 to negative 1. That means it went down 4. And the x's went from 1 to 3, so that means it went up 2. So y equals mx plus b. That's our slope-intercept form. That's what we wanted in, slope-intercept form. So we said the slope, m, is negative 4 over 2. That's the same as negative 2 over 1, or just negative 2. So we have y equals negative 2x. And now we need to find out what that b value is. Where does this cross that y-axis? So what we can do is just keep extending that slope. We said the slope is, if we rise 2, and run negative 1, we'll get one more of those ordered pairs. And notice it lands right on that y-axis. Okay, again with that straight edge, you can just keep that line. And then all we have to do now is count and find out how high on the y-axis does this cross. 1, 2, 3, 4. So this crosses the y-axis at 5. So that would be the ordered pair 0, 5. So that means our b value is 5. Now we have graphed it. Notice we have put that y-intercept in there. We extended that rise and run. Rise and run. Rise and run. You can keep going with those dots. Keep going with those ordered pairs. And then we found the y-intercept. So we've got the slope and the y-intercept. Negative 2 for the slope and 5 for the y-intercept. So slope-intercept form. mx plus b. M is the slope. B is the y-intercept. Thank you.